B's modulus?
90. Or no, 2.
Modulus.
2.
It's 2. How far is it from there to there?
2.
It's 2. It's pretty obvious. Okay, what about its theta?
90 degrees. 90 degrees.
Okay. Now, so that's nice. What about point C, which I'm going to call, which is a cube?
Cube. 1 plus I minus C 1 plus I minus C. So, it's
1
gonna be
plus
2I.
I.
It's gonna be 3I. It's gonna be, oh yeah, 3I plus 1.
You think so?
Yeah, 3I plus 1.
Okay, so first of all, here we have 1 plus I times 1 plus I, right? What does this turn into?
2I. 2I.
That's 2I. We already did that. We did it right there. This is going to be times 1 plus I.
2I plus
What's 2I times 1?
2I.
What's 2I times I?
Negative 2.
2I minus 2.
Yeah.
Interesting.
Yeah. So you go to the left 2 0 and then you go up 2.
Okay. Left 2, 1, 2, up 2, 1,
Up
2.
2. You got like,
There you go.
you dilate, buddy.
Well, it didn't dilate, because if it dilated, it would have multiplied both its
Scale
imaginary
factor.
and
Or the scale
real factor.
Yeah.
Okay, if it dilated, then it would be multiplying both its imaginary and real components by 2, right? If you're saying you dilate by 2. So if this dilated by 2, it would just be moving up here. So it both so that's not quite it.
Square root of 8.
Anyway, so let's go ahead and find the angle and modulus. So mod yes, square root of 8.
Square root of 8.
Yeah, so 2 squared is 4. 2 squared is 4. Square root of 8. Okay.
Oh yeah.
Okay, so what about the modulus? Or sorry, the argument.
It's gonna be 2.
It's 135, right?
90 plus 45.
90 plus 45, 135. Okay. I'll give you 3 guesses to the next point we're going to look at, and the first 2 guesses don't count.
Alright.
Let's look at 8 to the 4th.
Alright. It's gonna be
Okay, so
It's gonna be by 180.
it's 1
By
plus
2
let's see.
I minus
It's 1 plus I
2. 2I.
times 1 plus I. Hold your horses.
Wait, hold on. 2I minus.
Whew. Okay, so hey, what's 1 plus I times 1 plus I times 1 plus I?
2I
4I.
minus
2I minus 2. We just found that, right?
2. 4I.
So these 3 are going to combine into what?
2I minus
2I minus 2. So 2I minus 2 times what? 1 plus I.
That other one could be simplified, the modulus, it could be simplified to 2
Yeah.
square root of 2.
It can. It can become 2 square root of 2. Okay, so what is 2I times what? 2I
minus 2
minus 2.
minus 2
See
minus 2 negative 4. Negative 4.
Yeah, these 2 negative 2's combine into negative 4. 2I minus 2I is 0, so those cancel. Then we have negative 4. Okay. Okay. So what's this thing's modulus?
It's gonna be
So its modulus is just the length. It doesn't care about the sign. So what's its modulus going to be? 4. What about its theta?
90.
That,
Oh, 180.
180. Okay. square root of 2, then 2, then square root of 4, right?
Yeah.
Then 4.
It's going up by -4. Wow, instead of 4,
Yeah,
square root of 4 is 2.
Oh wait, no, sorry, you're right. You're right. You're right. You're right. Yeah, it was the square root of 8. Well, let's see. Just a minute. Let's go ahead and simplify this for a moment. It started at square root of 2, then 2, then it went to 2 square root of 2, then what? Then 2 times 2. What's happening each time?
2 is life, alright?
Remember, it's not dilating by 2, because dilating would be multiplying both of its real and imaginary terms by a constant. That's not what's happening. Okay, let's go backwards for a moment. Okay, let's follow this pattern and see what a to the 0 is.
1.
Anything to the 0 power is always the same thing. What is it? 1. Okay, fine. What's the modulus of 1? Modulus is going to be 1. Okay, and what's its its argument is what again? 0. Okay. Isn't that interesting? So we can clearly see a pattern, right? It's just not quite so obvious what the pattern's doing. So the angle's pretty obvious. It's increasing each time. But what's happening to its modulus? Okay, let's go ahead, let's take a moment and let's make a table. So let's see if we can find a pattern. It's not multiplying by 2. Okay, so just a minute. Let's go ahead and make a table. So, this is for the values of a to the n power. And let's make a table. by the square root of 2, so this becomes square root of 2. So in that case, 1 plus the square root of 2 should be times what? Let's see, what's 1 times the square root of 2? What's the square root of 2 times the square root of 2? 2. What's 2 times the square root of 2? Or 2 square root of 2, right? 2 times the square root of 2 is 2 times the square root of 2. Shocking, I know. What about the square root of, what about 2 times the square root of 2 times the square root of 2? Well, 2 times square root of 2 times square root of 2? 2. What did we get? 4. Does this work?
Yeah.
Okay. Looks like we may have a pattern. But what about here? This 1 is kind of, I mean, it starts on 1 fine, but how about going back to 1? Well, let's take a look. Let's see if we can write a formula for the modulus. So, well, let's see. So this is this right here, this is just the square root of 2, right? Yeah, square root of 2. And this is square root of 2 times square root of 2, right? And this is square root of 2 times square root of 2 times square root of 2. This is square root of 2, square root of 2, square root of 2, square root of 2. So, the next one would be square root of 2 times itself how many times? 5 times, right? So, it's going to be square root of 2 times itself 5 times. How can we represent that? Not 4 times. Square root of 2 to the 5th power. Okay, everybody, eyes up here. This is important. This is the big idea of today's lesson. So the modulus is changing each time.